All right, so today we're going to be talking about constant of proportionality. And basically, we kind of introduced this a few days ago and we've been working on it a little bit, but I just want to refresh our memories on how we can find this with tables and graphs and how we can write that as an equation. So our learning target is I can determine if two quantities are in a proportional relationship. And then based on whether or not they're in a proportional relationship, we want to try to start writing an equation. So we're focusing on tables and graphs. But first of all, I want us to just talk about constant of proportionality for a second. We know if something is constant, that means it does not change. So it's going to be the same throughout. And proportional means that two quantities are changing at the same rate. So if I'm comparing them, they would have the same ratio throughout the entire thing to be proportional. Now, if two quantities are proportional, then the common ratio that they have, whatever ratio they share, is known as the constant of proportionality. So that just means that it is constantly changing at the same rate. So you'll notice that I have K in parentheses there. We know with lots of things in math, there is a variable that represents that topic. So in this case, the variable that represents constant of proportionality is K. So as we start to write equations today to represent these proportional relationships, we will be using the equation y equals kx, where k is the constant of proportionality. X and y represent two quantities that are being compared to each other. So in this case, it's going to be ordered pairs in a table or on a graph that are comparing those two values that we see. So without wasting any more time, we want to make sure we commit all this to memory. Remember, proportional just means it has the same ratio. The constant of proportionality is that common ratio. So we're going to come back to that y equals kx equation in just a minute. Right now, we're going to start with finding the constant of proportionality in a table. So I have this table here comparing the number of trees to the number of apples. So if I'm comparing those, then the trees would be my x value, apples would be the y value. The equation that we're going to use to try to help us out to determine if there's a k value here is y equals kx. Now, our whole goal is finding the constant of proportionality. So I know that k represents the constant of proportionality. If I want to solve for k, then I need to isolate that variable. So right now, k is being multiplied by x. We know from our experience with solving equations that we can fix that really easily if we want to get k alone. So we're going to start by dividing by x on both sides to make sure that we have k by itself. So then that gives us y over x equals k. So that means for every ordered pair, if I write the ratio y over x, or if I divide y by x, I get the k value. So I'm going to try that with this table. So on the first one, we would have 26 over 2, because 26 is our y value, 2 is our x value. We're just plugging it in as that y over x ratio. We can do that for every point on this table. So we do 39 over 3, 78 over 6, 130 over 10, and then 146 over 12. The important thing here is remembering the order, because with ratios, order always matters. So make sure your y value is in the numerator and your x value is in the denominator. The second thing that I want to do, this looks really good. I've got all these ratios set up comparing my x and y values, but if I really want to compare them, I need to simplify them as much as possible. So I'm going to go ahead and simplify all of these. If I do 26 divided by 2, I get 13. 39 divided by 3, I get 13. If we work our way down and try each of those, we're going to get 13 every single time. That's really important because as we were talking yesterday and the day before, in order for a table to be proportional, the ratio has to be the same all the way throughout. So in this case, it's changing at a constant rate of 13. So we're multiplying x by 13 every time to get the y value. So our k value is 13 because it's constant throughout the entire table. And then we can use that to write the equation in that y equals kx form. I just plug in k now. So I have y equals 13x. So every time if I want to find y, I can just multiply x by 13. So then we want to do the same thing on a graph. So if we have a graph from what we've talked about before, we know it's really easy to check whether or not it's proportional. So in this case, I see that it is passing through the origin and it is a straight line. So we have a proportional graph on this one. So once I know it's proportional, I want to try to find the k value. So we're going to do the same thing we did on the table, writing ratios of y over x. In this case, I already know that it's proportional, so I can just find one of those points and solve for my k value. So in this case, I'm just going to find a nice pretty point. You could use any of these points on here since we know it's proportional. I like to start with some of the smaller ones because it makes the math a little bit easier for us. So our y value would be 92. Our x value is 2. We can plug those in and we have k equals 92 over 2. If we simplify that as much as possible, we get k equals 46, which means our constant change is 46. And you'll find that that's true for the entire graph. So if I did 4 times 46, I would get 184. And we could keep going and it would give us each of those points. So we can write an equation to represent this using that y equals kx form, where we plug in k because it's going to be true for every x and y values. So for every ordered pair, we know that y equals 46x or 46 times x.